anyone who may be watching this. Welcome to a Unit 4 review for Miss Cleveland's AP Environmental Science class. We start with Unit 4, Earth Systems and Resources at the beginning of the first semester. For the purposes of this video, I'm going to go lesson by lesson, starting with lesson 4.1, Plate Tectonics. So a little bit of a simplification, but the Earth is comprised of three main layers, which are the crust, the mantle, and the core. I'm going to focus in on the mantle because you kind of need to understand the form that the mantle takes to understand tectonic plates. So the mantle is this liquid layer of magma that stays liquid because of all of the heat from the Earth's core. Now, on top of the mantle, kind of quote-unquote float tectonic plates, which make up a layer called the lithosphere. And there are distinctive ways that we classify tectonic plates and their boundaries with their neighbors. So starting with the tectonic plates themselves, you have continental plates, which are massive, rigid slabs of rock that form the Earth's continents. They're thicker and they're less dense. Versus oceanic plates, which are large, rigid slabs of rock that form the ocean floor. They're thinner and they're denser. And these plates are always moving. Movement is driven by convection currents in the mantle, where hot material rises and cooler material sinks. And the ways that these plates move in relation to their neighboring plates are classified as distinct boundaries. For example, convergent boundaries are boundaries where tectonic plates collide and come together. When two plates meet, their interactions can result in various geological phenomena. Convergent boundaries contribute to the formation of mountains, volcanic activity, and earthquakes. This is a little bit silly, but to remember which boundary entails plates crashing into each other, think of cars crashing, both words that start with C, and pick out the only plate boundary name, convergent, that also starts with C. And then you have your divergent boundaries, which are when plates are moving away from each other. This movement results in the creation of a new crust as magma rises from the mantle, solidifies, and forms a new oceanic crust. Divergent boundaries are responsible for the continuous reshaping and formation of the Earth's crust. Now, I included this picture so you can see that this is generally happening between two oceanic plates, which is also why it's called seafloor spreading. And then finally, you have transform boundaries, which occur when two plates slide past each other horizontally. The movement along these boundaries can cause earthquakes as the plates grind against each other, which is also what we have here in California, a transform boundary called the San Andreas Fault. Lesson 4.2, Soil Formation and Erosion. If there's one thing that you need to take away from this lesson is that soil is not dirt. Soil is comprised of a lot of things, such as water, organic matter, mineral particles such as sand, silt, and clay, and even air, but it is certainly not dirt. Rather, soil is the foundation of terrestrial ecosystems. It forms when a parent material, like rock, is weathered, transported, and deposited over time. Soil is organized into layers called horizons, which together can make up a soil profile. However, soil can also be degraded by erosion, caused by wind, water, and other things that can reduce its fertility. Protecting soil also protects water quality since soil filters water as it percolates through. There are natural forms of erosion and preventable unnatural kinds. Lesson 4.3. Soil composition and properties. Now, to backtrack here, as a reminder, soil is made of many, many things, and its composition will also influence its many properties. So one of the things that soil is made up of are mineral particles, more specifically things like sand, silt, and clay. Now, the composition of sand, silt, and clay influences the soil texture. For example, here you can look at the soil textural triangle. The soil texture triangle is a tool used by scientists to classify the texture of soil based on its composition of sand, silt, and clay. The reason that this is so important is that those particular particles vary in size so greatly that the properties of the soil are very, very different depending on how much of each particle it contains. For example, larger particles like sand, there will be more space between the particles for water to pass through. So it will have something called a lower water holding capacity because water will drain through it very easily. A low water holding capacity means that it has high permeability. Permeability means that water will pass through with ease. Vice versa, a particle like clay, if there's more clay in a soil, it will have a higher water holding capacity because water will not be able to pass through. But because water is not able to pass through, it will also have lower permeability. Another thing to be considered in a soil's composition is the amount of nitrogen and phosphorus that it contains. Because nitrogen and phosphorus are the biggest limiting factors in a plant's growth. So the more nitrogen and phosphorus a soil has, the more fertile that soil will be. And another soil property is soil pH, which is a measure for how acidic that soil is. When the pH is lower or more acidic, there's less nutrient value and also this ability for that soil to start dissolving the naturally occurring aluminum in that soil, which also makes the soil less fertile. So there you have three more properties, nitrogen and phosphorus, soil pH, and soil fertility. The Earth's atmosphere is mostly composed of oxygen and nitrogen. Nitrogen is released into the atmosphere through denitrification, and oxygen is released through photosynthesis and plants. Water vapor, or H2O, can also be a major gas in the atmosphere. It is notably more concentrated around the equator than the poles. But there are also a lot of other players among gases, such as methane, carbon dioxide, nitric oxide, and ozone. Carbon dioxide, methane, and nitric oxide are all greenhouse gases that trap in heat from the Earth's atmosphere. All these gases are released when fossil fuels are burned. Since humans have burned an abundance of fossil fuels, greenhouse gas emissions are high, and that causes our planet to warm. Now that we've talked about the gases that our atmosphere is comprised of, let's talk about the atmosphere's layers. The first layer of the atmosphere closest to the Earth is called the troposphere, and it starts at ground level and goes up about 10 kilometers in altitude, which is the average height of like an airplane. And then above the troposphere, you have the stratosphere, which goes from about 10 kilometers to 50 kilometers, which is mostly composed of the Earth's ozone layer. And then we have the mesosphere, which is from 50 kilometers to 80 kilometers in altitude. The temperature decreases as you increase in altitude. It just gets colder and colder. And then you have the thermosphere, which goes from 80 kilometers to 100 kilometers in altitude. And finally, you have the exosphere, which is the very highest layer of the Earth's atmosphere and is located around 710,000 kilometers above the Earth's surface. Next, we have 4.5, global wind patterns. Global wind patterns are primarily driven by the sun's energy and the rotation of the Earth. These winds play a major role in distributing heat, moisture, and energy around the globe, which also affects our climate and weather. The Coriolis effect causes winds to curve as a result of the Earth's rotation underneath them. This is why winds in the northern hemisphere turn to the right and in the southern hemisphere turn to the left. Trade winds are found between the equator and 30 degrees latitude in both hemispheres. These winds blow from the east to the west are responsible for driving tropical storms and ocean currents. The westerlies are found between 30 and 60 degrees latitude. They blow from west to east. These winds play a critical role in the movement of weather systems across temperate zones. And the polar easterlies are winds that blow from east to west near the poles. They're responsible for for moving cold air from the polar regions. These prevailing winds, along with cell circulation, such as Hadley cells, Ferrel cells, and polar cells, create global wind patterns that affect everything from rainfall to the distribution of deserts, forests, and other ecosystems. 4.6. Watersheds. A watershed is an area of land where all the water that falls within it flows to a single point, like a river or lake or an ocean. They vary widely in size, from local areas to massive river basins like the Mississippi River Basin. The health of a watershed affects water quality, biodiversity, and human populations that rely on these water sources. In Miss Cleveland's class, we got the opportunity to go on a watershed restoration field trip, which I thought was really cool, but I digress. The characteristics of a watershed, such as its size, slope, land use, and vegetation cover, influence how water moves and how much water the watershed can absorb. Steep slopes lead to faster runoff, while flat areas can lead to more groundwater infiltration. Vegetation in a watershed acts as a natural filter, slowing down water flow, reducing soil erosion, and improving water quality by trapping pollutants. Watershed management is key to ensuring clean, sustainable water for communities. Protecting a watershed can involve practices such as reducing pollution, preventing over-extraction of water, and restoring wetlands to improve natural filtration. Next, we have 4.8, Earth's geography and climate. When we talk about weather and climate, we're discussing different timescales of atmospheric behavior. Weather is short-term, like temperature, humidity, precipitation, and wind, while climate is all of those things, but the long-term patterns of those things, like the averages of weather and the averages of humidity and precipitation and wind. Latitude is a major factor in shaping a region's climate. Areas closer to the equator, like lower latitudes, receive more direct sunlight, making them warmer, while areas closer to the poles, or higher latitudes, receive less direct sunlight, making them colder. The difference is a fundamental driver of the Earth's climate zones, from tropical to polar regions. Altitude also plays a role in climate. Higher altitudes tend to be cooler because the atmosphere is thinner and it can't hold as much heat. This explains why mountaintops are often cooler than the valleys below, even if they are the same altitude. Something else that we learn in this section of APES is how geography in any given area can influence the climate. And an example of this that I thought was really cool was the rain shadow effect, which occurs when mountains block the passage of moist air from the ocean. So as the air rises over the mountain, it cools and releases moisture as precipitation. On the leeward side of the mountain, the air becomes dry, the conditions are arid, and it's like a desert. This explains why places like the Atacama Desert in Chile on the leeward side receive almost no rainfall. And ocean currents also influence climate. We kind of talked about this earlier, but warm ocean currents like the Gulf Stream can raise temperatures in coastal regions, while cold currents like the California current have a cooling effect on nearby land masses.